Hello, everyone. Thank you for joining us today. My name is Yasmina Greco. I'm with O'Reilly Media, and I will be your host for today's webcast. Today, folks, we have a special treat for you all. Matt Richardson and Shawn Wallace presenting Getting Your Raspberry Pi Up and Running. Matt and Shawn are the authors of the brand new O'Reilly Media Make book, Getting Started with Raspberry Pi. We're really excited to have these gentlemen with us today to present this webcast for you all. As we get things started, I'd like to go over a little housekeeping to help you get the most out of today's webcast. You'll want to open your group chat widget if you haven't already done so. This is where we can interact with each other during the event and where you can submit your questions for Shawn and Matt. We find that our audience usually has a lot of good knowledge to share, so we encourage you all to chat freely during the event. However, if you have questions for Matt and Shawn, please preface them with a capital letter Q so we know that it's for them and we can make sure they see it for Q&A. You can also open, move, and resize any of the other widgets. If you would like to tweet from the Twitter widget today, you may need to give it permission to access your account, and it will automatically append the event's hashtag to your tweet so you don't have to. And today, our hashtag is Raspberry Pi, all one word. If you should have any trouble during the event, please take a look at your help widget. If you continue to have problems, please post it in the chat room and one of our staff will help you right away. For choppy audio or stalled visuals, please try refreshing your window. And remember, the best thing you can do for a good audio stream is to close any apps that could interfere. People always ask, so we'd like you to know we are recording today's webcast, and we'll have the archive ready usually within 48 hours. And folks, at this time, it is my pleasure to turn the program over to Matt and Shawn for their presentation. Hello, gentlemen.
Hello. Thank you, Yasmina, for coordinating this webcast, and thank you, everyone, for being here. My name is Matt Richardson. I'm on the line here with my co-author, Shawn Wallace. Hey, Shawn.
Hey, Matt.
So today we're going to discuss the very basics of Raspberry Pi, what it is, what you can do with it, and why it's getting so much hype. In our book, we introduced the Raspberry Pi from a maker, hacker, tinkerer perspective with step-by-step tutorials and projects that give you a lot of the basics you need to do some pretty cool stuff with it. So first of all, what exactly is a Raspberry Pi? At its very essence, the Raspberry Pi is simply a computer. You can plug in a monitor, keyboard, mouse, Ethernet to a router to connect to the internet, and you can use it just like a regular computer. And instead of Windows or Mac OS, it's running Linux, a free operating system. Now, you'd probably consider the CPU to be a bit low-powered compared to the processor on a typical desktop or laptop computer that you'll buy today. What distinguishes the Pi is its price. So it's sold for $35 from Raspberry Pi's official distributors, and it's available from other sites for a slight markup, bringing the price to around $40 usually, but still, I think, very cheap for a computer. Now, before we go on, I wanted to take a minute to talk about the history of Raspberry Pi and give a little bit of backstory. So a few years ago, Evan Upton and his colleagues at the University of Cambridge Computer Science Department noticed that the students who were applying to their program didn't have the skills that they used to. The thought was that kids these days don't really tinker with computers as much as they used to in the days of, let's say, the Timex Sinclair, the BBC Micro, the Commodore, or the Amiga. And these days, students would sometimes come in with web development experience and usually not a lot of lower-level programming experience. That is to say, like writing software that can be compiled or tinkering with hardware and so on. At the same time, since mobile phone and tablet processors have been getting less expensive and more powerful, it really cleared the way for such a cheap and hackable computer. The best part about it, I think, is its price. It means that you can hack and tinker without fear of breaking something that costs a few $100s. And a couple months ago, I read a BBC article that quoted Linus Torvalds, the founder of Linux, and he said that Raspberry Pi makes it possible to afford failure. I like that a lot. It's a huge part about why we at Make like the Raspberry Pi too. Beyond being a computer, the Raspberry Pi has a few extra features that make it great for makers and those interested in electronics projects. We're going to talk about that a little bit more in detail later in the presentation, but I want to give you an idea of what people have made. For instance, their own appliances like this radio. It's called a Magpie radio that reads off tweets to you. Another group made their own supercomputer cluster out of 64 different Raspberry Pis to learn how computers can work together to do jobs. And then other people use it as a gaming console or a media server. And these are just a few examples of what can be done with it. And by the way, if any of you out there create something cool with Raspberry Pi, we would love to hear about that. With that, I'm going to turn it over to Shawn, who will talk about some of the specifics of the board and how to get it up and running. So it's all yours, Shawn.
Thanks, Matt. So here on the screen we have there are two different models of the Raspberry Pi out there on the market right now. The Model B was the first to come out, and as you know, some of you may know, these were kind of hard to get last year. They started showing up in the UK last summer. You could get them on eBay for a while.
Shawn was talking about the Model A and difference between the Model A and Model B, and Model B has been out for a little while. Model A, which is less expensive, only recently came out. It does not have the Ethernet jack on it, and also uses less power. So if you're thinking of an application that is a little bit more power hungry, or you need to be conservative with power, let's say if it's a battery-operated application that you want to use the Raspberry Pi for, you may want to consider using the Model A instead of the Model B. Let me see. Let me bring you through here to the next thing.
So this image here, this is actually the first illustration in the book, and it may seem a little odd to kind of start with sort of a detailed schematic of a circuit board, but that's actually this is actually what you get when you take it out of the box. I'm just going to go really quickly. If you look at right in the center of the board is the processor, which this is based on a Broadcom processor. And it's an ARM architecture. It's probably most comparable to something like the Kindle Fire, although it's not related to the Kindle Fire at all. But that's probably about the same capabilities and kind of based on that mobile chipset. Moving around the board on the bottom side, you'll see there's an SD card slot. So your operating system. All your file system is all running off an SD card. On the right-hand side, there are two USB ports on the Model B. There's a wired Ethernet jack. There's analog audio out, and there's also composite video out on the top of the board there. One of the things that like Matt said, we really concentrated on using the Raspberry Pi for making things rather than just using it as a programming platform. And one of the things that enables that is here, if you look at the very top left of the board, there are 26 general purpose inputs and outputs. So these are all pins that can be accessed directly from the operating system. So you can write a Python program that would either read an input, a digital input, or toggle a digital output. There are also a few different serial protocols that are broken out on this header. There's an SPI interface, and then there is a I2C interface, and these are very common when you're working with integrated circuits or things like SD cards or reading sensors. It's a way of communicating with other chips. The other two interesting headers on the board, if you look at B and C, these are there's a camera serial interface and there's a display serial interface. And we're probably real soon now there will be a really inexpensive camera module for the Raspberry Pi. And you'll also start seeing touch screen interfaces. So I think this year you'll see a lot of people making DIY tablets and other devices with the Raspberry Pi. But they're not quite on the market yet. So the other few things you need to get up and running need an SD card. If you're probably keyboard, mouse, if you're going to run it as a standalone computer. And the most important peripheral is your power supply. It takes a regular micro USB power adapter. Your cell phone charger may not provide enough power. You generally need about or enough current. You need about 700 milliamps or so. So a lot of people, vendors have, including AIC, we have our own Getting Started kit that has an appropriate power supply in it. And another thing, because you kind of just get it as a bare circuit board, another thing that you might want to think about is getting a case. There's actually kind of a surprising array of different cases on the market now. This image is one. This is the Pi bow, which is a bunch of laser-cut acrylic sheets that you can assemble into a case. And this is kind of an interesting example. They've sold about 15,000 of these cases, and kind of created a little cottage industry just around the Raspberry Pi market. So I'm not going to go into once you there are a number of different Linux distributions for the Raspberry Pi. The official distribution is called Raspbian, which is based on Debian Linux, and it has all of it's compiled with all of the Broadcom drivers, ready to go right out of the box. So to get started, you would download that, burn that image onto the SD card, and then boot up the Raspberry Pi. So I'm going to boot up the Raspberry Pi right now, and give you an example. Let's see. Share the screen, and it should come up. There are a lot of reasons that the Raspberry Pi is successful. They're actually pushing. I think they're pretty much near 1 million units sold in the past year. And I think one of the reasons is that, not the only reason, but they have a nice logo too. I'm not sure if you can see. Oh, there we go. Okay, so this is a Raspberry Pi desktop right here. And so I'm actually running this right now as I'm actually running a virtual VNC server on the Raspberry Pi. And I have this, I pulled this up on my Mac so I could share the screen with you. And if anyone's interested, I could show later how that happened, how to set that up. So this is the stock Raspbian distribution. I've installed a few other pieces of software on here. Like Matt was mentioning before, this one of the goals is to teach young people how to program. And with that in mind, it has Python installed right out of the box. And it also has Scratch, which I was kind of surprised at how many young people I've talked to have been exposed to Scratch either in school or at home. And so Scratch is a very simple visual block-based programming language. And what's kind of neat is that you can build programs in real time. It's all sprite-based, so it's good for making games out of the box. So here, I'm just changing this right in real time. There's a little simple Scratch program. And let's see, a little random element. There we go. Random walk, so that was pretty easy. All right. Let's Scratch. And let's see. There are, so because this is a stock Debian distribution, there are a lot of, one thing that Linux does really well is that other operating systems don't do as well is package management. So there's a huge array of programs that are available, and it's fairly easy to manage them. One thing that's kind of interesting is the the Raspberry Pi Foundation launched an app store back in December. If you look at it, this is the App Store application here. Doesn't look like it has really taken off yet. Only about 50 apps or so in there, but we'll see how that turns out. You don't have to go through the App Store in order to install programs. Let's see. A few other potential. Here I have Conterface installed in my Raspberry Pi, which is a popular program for driving 3D printers. That is another potential application for Raspberry Pi. When I first saw the Raspberry Pi, I got excited. I've been working with some friends on using the Pure Data audio synthesis environment. And turns out Pure Data works on the Raspberry Pi. An example here, you won't be able to hear any of the sounds, but and so this Pure Data is a sort of a patching language for creating sounds, and that's sort of like a perfect example of what you would use the Raspberry Pi for. It's something that kind of requires more processing power than a microcontroller. So this is something that you could embed. You could create your own musical instrument using the Raspberry Pi, and people are doing that. I'm going to go back to slides. So so in the book we cover getting up and running, and we cover sort of all the basics of Python and Scratch. We found that in the book there are a few Python modules that are particularly useful with the Raspberry Pi. There is a GPIO library which lets you access all of the input and output pins. Pygame is another is a framework, a Python framework that was created for making games, but we've also found that it was an easy way of doing multimedia scripting, where you can you can launch videos, or you can launch sound samples and using Pygame. And there's some examples in the book where and maybe Matt will show you one of those afterwards. Also in the book, we use Simple CV, which is a computer vision, so it's a really simple wrapper for computer vision library. So you can do things like face detection, blob detection, movement detection, with the webcam, or we also, PySerial is a Python module that lets you talk to the serial port, which is useful for if you want to integrate with Arduino or some other serial device. And then finally, Flask is it's a web framework that's really handy. That's also in the book. So Pygame is a Pygame logo. All right. So here's a simple example of how you would use Pygame to play back a sound, not to create a game, but so here, if you just kind of standard Python, there's a mixer object which will load sounds, and you can actually have multiple sounds streaming all at the same time. And there's one more example from the book. Here's another use for Pygame is that it actually has a MIDI module built into it. So it's really easy to hook up a MIDI instrument and actually create Python programs to play a MIDI instrument, make music. So one thing, when the Raspberry Pi first came out, a lot of people were wondering if this was kind of an Arduino killer. Arduino being the microcontroller platform. Similar price range, but microcontrollers are much more limited than full computers. But it turns out that Arduino and Raspberry Pi actually work really well together. They're complementary. There were a number of places where you would actually choose Arduino over Raspberry Pi and vice versa. A few of those differences are so the Arduino design is based on the AT Mega microcontroller, which was kind of designed for automobiles. So it's a very robust microcontroller. It's great in for students just learning about physical computing. The Raspberry Pi is kind of the chipset is designed for mobile devices, and so it's not quite as robust as the Arduino. The other big difference between microcontrollers and an actual computer like the Raspberry Pi is that the microcontroller operates in real time. So any application where you need something that is going to execute every single clock cycle, you would use a microcontroller for. So, for example, if you were creating a 3D printer, your stepper motor driver, you would use a microcontroller like Arduino, and then maybe you'd run the host software on the Raspberry Pi. So anyway, we found that Arduino and Raspberry Pi work really well together with the Raspberry Pi acting as a host. So here's an example of just looking at Arduino and a Raspberry Pi up together. What you find is, and we talk about it a little bit in the book, that when you're using a microcontroller in the Raspberry Pi, you're generally communicating over a serial connection between the two, and you immediately find that you have to start creating a protocol that both devices can understand. There are a lot of existing protocols, but very often it's hard to retrofit them. It may not be right for your application. So anyway, it's an added layer. So there's also, if you want to, we're also starting to see some products sort of addressing this area of using microcontrollers along with the Raspberry Pi. So this is a product called the Alcala Mode, Raspberry Pi Alcala Mode, and it actually sits right on top. I don't know if you can see the headers, but it sits right on top like a little daughter board, and it's basically an Arduino that sits on top of your Raspberry Pi, and talks directly using the serial ports on the GPIO header. Speaking of GPIO, I'm going to hand it back to Matt, who will talk about a little bit the general purpose input and output pins a little bit more.
Great. Thank you, Shawn. So we discussed how the Raspberry Pi isn't just a computer. It has more features that make it friendly for makers and their products. And the GPIO pins on the board are just one of those features. So as Shawn mentioned, GPIO stands for General Purpose Input and Output. And it's a way of integrating the Raspberry Pi into digital electronics projects. The physical pins can be configured for a bunch of different functions, but by default, the Raspberry Pi has a few that are set for GPIO, as you can see here in this graphic. As the name suggests, the pins can be set either as an input or as an output, and I'm going to start with output first. So as an example, the most basic type of output, getting started with Raspberry Pi walks you through how to connect a simple LED and turn it on and off from the command line. The Linux kernel has drivers to control the GPIO, and Linux lets the user control the pins by writing to special files in a virtual file system. In fact, they're not really actually files. It's a way of accessing this hardware through using a file system. What's great about it is that no matter what programming language you use, as long as you can write to a file, you can turn the LED on and off. And not only that, but the LED represents only one small possibility out of all the possible things you could use. So, for example, with the right circuitry, you could use the GPIO pins to control, let's say, sprinklers, your stereo, motors, a lamp, and on and on and on. In fact, the book shows you how to use the Linux task scheduler cron to turn a lamp on and off, and which is essentially just turning your Raspberry Pi into an advanced outlet timer. And the best part about that is that it's extensible. You can take that project even further, and I'm going to talk about that a little later. And if writing to a file is how you control an output, then it makes sense that reading a file is how you read an input. In the book, we go into detail on how to hook up a simple button and use the command line to read whether or not the button is pressed. And it can be used to read the state of not just buttons, but like switches, pedals, door security sensors, so on and so forth. So we're giving you sort of the basics, the basic tools you need that you can build on. But we also throw in a few projects. And I actually wanted to show you something real quick. This is, I've been using this. It's called the Pi Cobbler. This is a product that Adafruit makes. And it takes all those pins from the Raspberry Pi and brings them over to your breadboard on a ribbon cable, and it makes it really convenient to work with it. So if I were to give a tip about, if you're new with working with electronics, using this makes it a lot easier to experiment, mostly because all the pins are labeled on this device, and it makes it easier to find what you're looking for, whereas on the Raspberry Pi itself, the pins aren't labeled, and it makes it difficult. And so this is one tip that we talk about, is using a product like this. And in MakerShed's Raspberry Pi Starter Kit, there include a version of this product that you can use if you're looking to get started with electronics, or you're just looking for something to make it easier to prototype with. So as I mentioned, you can use almost any programming language you want to read and control the pins. In the book, we show you how to use Python to do that. On the Raspberry Pi's Raspbian distribution, the Python module is already included, which lets you control pins using a relay, using a really simple Python syntax. This Python script that you see up on screen blinks an LED, turning it on for 1 second and then turning it off for a second in just a few lines of code. And one of my favorite parts about it is that you can use the GPIO Python module together with any of the other Python modules that are out there so that you can integrate your electronics into more complex projects really easily. Let's see here. Okay, so for instance, we can show you, in the book we show you how to connect a USB webcam to the Pi. Shawn mentioned that there is the CSI, the camera serial interface, and soon we're going to be seeing hardware that will connect to that. But since there's USB ports on the Raspberry Pi, you can just connect a regular USB webcam to the board and control it and take pictures from it and maybe even video. And we made a project called the Webcam Photo Booth that uses a computer vision algorithm to detect faces with simple CV, and then it draws a little mustache on the face. And this is activated by pushing a physical button. So we're combining the GPIO module to read the state of a button, and we're combining it with the computer vision algorithm. And I think this really shows the strength of the Raspberry Pi because it lets us combine these really, really easily. So another project uses push buttons to play sound samples. That Pi game module that Shawn was talking about, we use that to control, make your own little soundboard so you can set up buttons, and every time you push a button, a different sound effect can play. For instance, cheers or boos, applause, laughter, or maybe if you want to make one of those like Arnold Schwarzenegger soundboards, you could do that too. Whatever sound files you can find, load them up onto the Raspberry Pi, and then you can be hitting buttons and playing sounds. That can be also extended to play videos on screen, perhaps. Maybe you have a project that does that. And as I mentioned, you can hook up AC loads such as lamps to the Raspberry Pi. We show you how to use a device called a power switch tail, which has a relay inside, so that you can use that small bit of current that comes out of the Raspberry Pi to control something that takes a lot of current, like a lamp, a coffee maker, and so on and so forth. One of my favorite projects that takes a step further and walks you through how to set up a web app on the Raspberry Pi, basically a fully featured web server. So we use Flask, which is a web framework for Python that makes it easy to create dynamic web apps. When you use Flask along with the GPIO module, you can make a web server that controls appliances, and we show you how to do that. And one of the great things about it is that you write the code blocks once, and then if you want to add a new lamp or you want to add a coffee maker, it's a matter of putting in a little extra information, and you're actually reusing the code to control those devices. So all that is in the book, how to do that and how to take care of that. That gets you started. And unless there's something else you want to add, Shawn, should we take some questions, I guess?
That sounds great.
Great.
All right. Thank you so much, gentlemen. And as you can imagine, we have a lot of questions coming in. So folks, keep them coming. Now's the time for Q&A. Open that group chat, type in your questions, send them in, and we'll get through as many as we have time for. All right. We'll take them in the order they came in. Emmanuel would like to know why Raspberry Pi community is not pushing more to have Ubuntu supporting ARM version 6.
I don't know that. I'm not sure. I'm not that in tune with that, with the behind-the-scenes workings of that.
I mean, I have a few guesses, but I have guessed that there perhaps is some overhead involved in the Ubuntu distro, that's mostly the Raspberry Pi people and what their developers are working on.
Oh, okay, thank you. And our next question here is from Praveen. He'd like to know, how useful is Raspberry Pi to learn programming on the computer?
I'll take that. How useful is it? It's funny. We found kind of our exploration of working on this book, like Matt before, we really ended up focusing more on using the Raspberry Pi for making things, rather than as originally intended as an introductory programming platform. And I think some of the Eben Upton, who's the founder and creator, I think he was maybe a little bit surprised too that more people were using this to really to hack on and make things and as a programming environment. So I don't, I think it is useful. It's really inexpensive. So I think that could make it more accessible to some people maybe who couldn't afford a $1,000 laptop. So I think it remains to be seen.
Great, thank you. Next question here from Douglas. He'd like to know, can you SSH or VCN to the Wi-Fi dongle?
Yes, you can.
Okay. Next one here from Joe. And Joe's question is, your picture from one of the slides shows a Class 4 SD. Is that the minimum class rating, or will older Class 2 cards work?
I believe the Class 4 is required. I think that is related to the speed at which the processor can write to the SD card. That would be a Class 4 minimum.
Okay. Next question here, I'd like to know, can we run PHP or Ruby languages on the Raspberry Pi?
Yes, and I've done it. It works.
In Perl.
Very cool. Ryan would like to know, does Pi have GPU hardware on the SoC, or do you have to rely on software rendering?
It does have a GPU, yep. And that is, the Raspbian distribution is actually has all the correct drivers. There's some proprietary layers in there, but Raspbian will take full advantage of the GPU.
Great. And Jack would like to know if you two could share your thoughts on an interface with TI Launchpad.
I haven't used the TI Launchpad at all yet, so I don't want to say anything about that.
Sure. I would imagine, I haven't really used the Launchpad either. The issues with integrating with a microcontroller, you'd probably be talking to it over serial connection. The Raspberry Pi is not 5-volt tolerant, so I'm not sure. I can't remember if the launch pad is 3.3 volts or 5 volts, but if it is 5 volts, you would need a level shifter, and then it's just a matter of working out some sort of serial protocol between the two. So I would imagine, sure, you could use it.
Great, thanks. And there's a few questions asking about Java, if you can run Java and do processing on the Pi.
Well, the latest I've heard is that they're getting close to being able to do that. I guess the RAM issue right now, running the Java virtual machine with the RAM situation, I think is difficult. But from what I hear, they're working with Oracle to get that working. Shawn, do you know anything else about that?
No, I get the same thing. I do know that if you're asking about processing, the programming environment, that does not work right now on the Raspberry Pi. But you can run, I have run the Arduino IDE, which is kind of based on processing. It also uses Java, and that actually works fairly well. So.
All right, another question here. We'd like to know, is it true that there is no clock? The clock is software emulated?
Yes, that's true. When you boot up the Raspberry Pi, it finds the time over the network. It uses an NTP protocol to check to see if it can get the time. There's no real-time clock. There's no battery to hold the time when you power it down. So if timekeeping is important to you, you need to make sure that when you power it up, it does have a network connection.
And that's someplace where some vendors are filling in some of these gaps, like the Alcala Mode shield that I showed earlier actually has a real-time clock chip and a battery on it to add that capability.
Thank you. Let's see here. A question up from Praveen. Can we start an Apache web server on the Raspberry Pi?
Yes, you can. In fact, any of those web servers you can run. You may want to consider running something with a little less overhead as opposed to Apache. If you can get away with using light HTTPD, that may be a little bit easier on the Pi because you have to remember there's only limited resources available on the Pi. But you can indeed run Apache. Check out Nginx. There are a few people, I've read about a lot of people using different kinds of web servers on the Raspberry Pi. And also, of course, we mentioned the Flask web framework, which lets you do dynamic web hosting. And Shawn, what's the my mind is blanking. There's that Python module that is the simple HTTP Python module?
Yeah. Yep. Yeah, it's like a one-liner in Python.
Yeah. So there's basically you can run this one Python. You can run Python with this module imported, and it'll take the files in that directory and serve them as though it's a web server. So if you don't need all the features of Apache, you may want to consider something that's a little bit more slimmed down.
Super, thanks.
Go
ahead.
I have something here. I'll share my screen again. I have this is a programming environment called from Adafruit, and it's called the Raspberry Pi Webide, and this is sort of a really interesting phenomenon with some of these computer on a board environments. BeagleBone has sort of a similar programming environment where it's all web based, and the BeagleBone is based on an IDE called Cloud9, and the Raspberry Pi, the web is basically you just point, if you look up, this is just a web browser, works in Firefox, and here I'm just pointing at the Raspberry Pi, and it basically gives me a window where I can type in a Python program, go to Hello World, and I can run it directly in the browser. And it's actually integrated with Bitbucket, so there's version control. You can manage all of your programs. in the cloud with Bitbucket. So this is kind of another alternative way of programming Raspberry Pi, kind of in a headless manner. So this could be sitting sitting out up on the roof with a webcam attached to it, and I could still access it over. I can still program it directly over the network.
Yeah, and this is something you'd have to install if you wanted to use it. Or Adafruit actually also has their own Linux distribution called Occidentalist, which has it already installed and running, along with a few other helpful tools that they created.
Wonderful. Thank you so much for showing that. We have a lot of questions coming in about the USB hub on the Raspberry Pi. A question here says, I run the PC laptop, but the Raspberry Pi simply won't detect it on any hardware connected to the hub, the USB hub. Can you talk a little bit about that?
Yeah. Shawn, do you want to take that, or you want me to talk about it?
No, go ahead. You start.
Yeah, so it can be difficult sometimes to get USB devices working on the Raspberry Pi. Many times the issue is an issue of power. You first of all want to make sure you're using a powered USB hub so that the device itself, the peripheral, is getting enough current so that it can be recognized by the system. And that's I think, is a very common problem, because not enough power will come through the USB ports on the Pi itself. The other issue is that you want to make sure that the peripheral itself is something that the Linux kernel will recognize and will know what to do with. There's a site called elinux.org that has a list of peripherals that have been proven to work with Raspberry Pi, and they may include notes or resources that will help you get things working that you may not be able to get working. Other than a power issue or maybe a kernel driver issue, Shawn, do you think there's anything else that people might try?
It's probably one of those. And just another note on the power issue. Some of the earliest revisions of the Raspberry Pi, the ones that came out last summer, I would say before October or so. If you got your Raspberry Pi very early, there are some fuses, poly fuses on the board that limit the amount of current that can be supplied to the USB. So on those very early Raspberry Pis, the USB port is just not up to spec, kind of by design. But the later boards should be able to provide enough power.
Right, and we have another question here now from Lucas who'd like to know, can the Raspberry Pi be powered using a battery?
Sure. Well,
yes. Yeah.
You really need a regulated power supply. So you would need, because it's powered directly by the a micro USB jack that just provides the power, so the serial part of the micro USB isn't hooked up. And so I would say you can't really hook the battery directly up because you won't be getting exactly 5 volts. But I think you really need some sort of additional regulated circuitry or a regulated power supply.
Yeah, and you can't connect the battery directly up to it, and you could use additional circuitry. If you're looking for something that's right off the shelf, sometimes there's devices that are battery packs that are meant to charge cell phones. They have basically a bunch of batteries inside and a regulator. I've heard of people using those to power their Raspberry Pi. Just a word of caution, do your research before you hook it up and make sure that other people have found that it's fine. There is one battery pack that I have called DigiPower, which it's made for and it's marketed to be a spare battery for an iPhone or an Android phone. It has a USB plug on it, so you can plug your phone into it and get power on the go. that does indeed work to power your Raspberry Pi with a battery. So that's a good off-the-shelf solution. But if you've got the electronics experience, definitely try with using a 5-volt regulator.
These are all product ideas.
Yes, yeah.
Very great. Thanks so much. More questions coming in. Let's see. Patrick would like to know, what apps from the App Store have you found to be the most useful?
I have only been downloading the Magpie, the magazine. So far, that's the only one I've tried. It's just the PDF of the Raspberry Pi magazine, and been flipping through that. I love that magazine, and it's great to be able to download it right from the store and read it right on the Raspberry Pi. Shawn, have you downloaded any actual applications?
I downloaded FreeCiv, which is the open source Civilization clone. Just tried that out. I heard that they're working on Minecraft, which I think will come through the App Store, I believe, but that's not available yet either. The App Store has not. Just looking at it now, it doesn't really seem to have taken off yet, and I don't know if that's just because it's sort of the wrong. I don't know. It's this is a different environment than Apple's App Store. I just don't know if it's the right metaphor for the right approach. So we'll see how that evolves.
Okay, another question here. What LCDs are supported?
Well, you can use a lot of LCDs just through the HDMI connector or the composite video connector. But Shawn, do you know of the LCDs using the LCD, actual LCD interface on there?
I don't think I don't think the display serial interface has drivers yet. I did see. I think Adafruit has a kind of a hacked up tablet screen that they were using. To tell you the truth, I don't know how they were interfacing with that. I think they were going through the it's one of the other serial adapters, but I could look.
Okay, we'll take another question from Ryan. Would like to know, is Raspberry Pi an open platform? I am not seeing schematics and board layouts like with the Arduino or Panda.
There are schematics. It's not open is I wouldn't call it open hardware really. And the other thing is so much of the design is integrated with the Broadcom chipset, and basically no one else can get those chips. It's the same price and same quantity, so it's kind of interesting. It would be very hard to make something. It would be very hard to make a clone that was at the same price point. Not that's not your question, I know, but the schematics are available. I don't think the board design is published.
Okay, we have a question now from Daniel, who sounds like he's got a real problem here. He says, "Hi, someone else set up my Raspberry Pi. He's not available at the moment, and I'm stuck, not knowing the login or the password. Fedora install. Is there a way I can reset these?"
Oh no. If you have the Raspbian distribution, the login is Pi and then Raspberry is the password. But on Fedora, I'm not sure what the default would be. Luckily, you're not totally out of luck, because you can if you can grab another SD card if you want and put Raspbian on that, and you can still use your Raspberry Pi. You're not totally locked out of your Raspberry Pi. And if there's nothing really on the card and you haven't really used it yet, you can always just totally rewrite the card again from scratch. But Shawn, you don't know what the default password would be for Fedora install, do you?
I don't know. could look it up.
Okay, thanks. We have a question now from Paul. He's heard OpenFrameworks will run on the Pi. Is that correct?
Yes, I'm a member of the OpenFrameworks developer list, and I've been watching the conversations going on there. OpenFrameworks is a wonderful graphical programming language. It uses creative coding, and I'm really, really excited to use it on the Raspberry Pi. I haven't had a chance to try it myself, but it looks like from what people are talking about on the developer list that they're having success. And I think it's a great thing, and this is one of those things I've been talking about with a lot of people, because if you can, use Raspberry Pi's GPIO function and have it control some, something on a monitor that looks beautiful. And if you've ever seen an OpenFrameworks project, I mean, they just make these beautiful, beautiful visualizations. So I'm really, really excited to see where people take that, and I'm actually really, really eager to get OpenFrameworks going on the Raspberry Pi so I can see what I can do with it and see what projects come out of that. So I think there's a huge potential there. So if you're interested in graphic programming and doing things on screen that are interesting, I highly recommend people check out OpenFrameworks and see how they can get that running on the Pi. That's a great question.
And along those lines, we have a couple more questions on what you can run on the Raspberry Pi. Some would like to know if you can run Flash.
No. Sorry. No, there's ways around it though. You can play some Flash videos, and I cannot remember off the top of my head what the app is called, but there's some way that you can indeed play a streaming Flash video. Shawn, do you know what that is?
No, I don't.
I'm sorry. Yeah, I've heard of some people having some mixed results, being able to do very, very limited Flash stuff, but on the most part, yeah, Flash is kind of off limits.
Thank you. Another question here. How about NodeJS? Can you run that?
Yes, you can. And in fact, I think I'm pretty sure Adafruit's Webide is using Node.js to present that web-based programming environment. That's all running in Node. You have to fact check me on that, but from what I can tell, yeah, Node.js, that'll work fine.
Super. A question now from Matthew. Will the camera port on the Model B offer more efficient camera capture than might be offered from the GPIO or USB port?
I'm going to take. I don't know for sure. I'm going to take a stab that yes, it is. The USB webcam framework is a little limited, and I'm only taking a guess that camera serial interface is going to be a little bit more responsive. I saw a demo of it, and I think it was doing, I want to say 720p video, and don't quote me on that either. But my hunch is that it would be better than the USB webcam interface. Shawn, do you have any insight on that at all?
I don't have anything else. I think that I do know that there is a prototype camera, and it should be out. I think they're expecting it in the first quarter, so we'll find out soon.
Okay, another question here, and folks, time is starting to run down for questions, so we'll take as many as we have time for. Fred would like to know if you two can speak a bit about the comparison between BeagleBone and Raspberry Pi.
Yeah, sure. So BeagleBone there's a few differences. I would say there's two main differences between the BeagleBone and Raspberry Pi. The first is that the BeagleBone doesn't have an onboard video connector of any kind. So no HDMI, no composite video out. Raspberry Pi does have that. But what the BeagleBone has that the Raspberry Pi doesn't is an analog to digital converter, so that you can read sensors that are like let's say a temperature sensor or a light sensor. Now, that doesn't mean you can't do that with the Raspberry Pi. It's just that the Raspberry Pi doesn't do that natively, and you have to use extra circuits. You have to wire up an analog to digital converter so that you can read analog sensors using the Raspberry Pi. But it's just built in on the BeagleBone. And those are two main differences between the Raspberry Pi and the BeagleBone. You can get a BeagleBone cape, which is like an Arduino shield, an attachment that goes on top of the BeagleBone that does give you video output, though. So in either way, you've got some solution to the problem, but those are the two main differences in my mind.
I think the other difference also is just the developer community.
Oh, sure, yeah.
I think there's been a lot of excitement about the Raspberry Pi, I've just seen like talking about OpenFrameworks or Pure Data, because of that excitement, I think everyone was like, oh, let's see if I can get my project running on the Raspberry Pi, where I haven't seen quite the same excitement about the BeagleBone.
Okay, let's see here. Question from Eve. Eve says, no sound when using the Scratch programming environment. Cat does not meow. On Raspbian, distro configuration issue, or is it a known problem?
Good question. I guess it depends. Let's see. So the analog audio out on the Raspberry Pi is a bit wonky. So if you're using that, I could see that not working. The HDMI audio out should work. I don't know if I've actually tested Scratch with. I have. No, I have done it. I have used the analog audio out. So I'm not quite sure. It just might be. It should work. It might just be a configuration problem.
Questions here. We do have one from Richard. How about going? Richard, you asked a question about going over the. Let's see if we can find it back here. The alpha charts. Was that perhaps a slide you guys showed?
The what?
The alpha charts? Maybe we're not understanding the question, Richard, if you can clarify. Okay, we'll skip that one and go to another question. Okay, the Raspberry Pi versus the Arduino. Again, your thoughts on both?
I think they work. You can think of them as complementary. One of the big differences is if you need something to happen in real time. An example is like a separate motor driver where the timing is essential. If you're writing a program on the Raspberry Pi, you're actually running in kind of a multi-threaded, multitasking environment where your Python, say you have a Python program that is keeping time. Your program may be interrupted, at the operating system level for some other process to run, and so it's trickier on the Raspberry Pi to keep exact time. Microcontrollers do that really well. I just think in general, like if for student, if you have a group of students learning electronics, hooking up circuitry, you can do that with the Raspberry Pi. I think it's a little bit more dangerous in the sense that it's probably easier to destroy a Raspberry Pi by creating a short circuit and hooking something the wrong way up to one of the pins rather than an Arduino. So I think an Arduino is kind of better for general purpose prototyping. Raspberry Pi is great when you need more processing power, or if you want to integrate with the internet or other web systems, things like that.
Yeah, and to take that just one step further, if you're making a project and you don't need everything that the Raspberry Pi affords and you only need what the Arduino has, you probably ought to stick with the Arduino because as you add more complexity, it just means more things can go wrong. And you have more control over the things that are going on the Arduino if your project is pretty simple. And I would recommend not using the Raspberry Pi if it's just a matter of using some buttons and LEDs. Stick with the Arduino. It's pretty simple and straightforward, and you're not going to have to deal with extra things going wrong due to the extra complexity.
Fantastic. And with that brings us to the top of the hour. So we are going to say a very big thank you to you gentlemen for presenting an outstanding webcast for us today. It was extremely informative and fun. So we thank you so much for that. Folks that attended, thank you so much for attending the webcast, and we hope you have benefited from it. A couple of announcements as we wrap up here. Matt and Shawn's book, Getting Started with Raspberry Pi, is the O'Reilly Deal of the Day, and we've pushed out some codes to you all in your group chat. So if you didn't open it, please do. Some good information there to take advantage of. You can get that book today, O'Reilly Deal of the Day, at a really great price. Visit O'Reilly.com. Look on the right-hand side. You can't miss it. It's right there. As well, our friends at Maker Shed has an extremely fantastic offer for you all for attending the event today. We pushed out the coupon code. Use PICAST, P-I-C-A-S-T. That's your code. It'll save you $30 on the Getting Started with Raspberry Pi kit while supplies last. So you don't want to miss that. The offer does expire at midnight tonight, so please do take advantage of that. Again, we thank you, Matt. Thank you, Shawn. Thank you, everyone, for attending. This will conclude today's webcast. Goodbye, everyone.